Very good morning to all of you. So, several lectures have been going on online for the last several days. So, few more lectures have been added so as to benefit you all. So, in today's lecture, we will be going to discuss something about heat portion. So, as you can see the name thermometry. Now, in physics, there are different segments in which you can say the chapters have been divided. You have seen various chapters, you have got an idea or feel of several chapters like motion, kinematics. Then you have also seen there is a section called current, electricity and all the important phenomenon associated with it. Later on also we will study many things related to current and all. Similarly, we have a segment called heat where we will be discussing the effects of heat, the ways of heat transfer, okay, and then how the heat energy when supplied to solids or liquids or gases, what effect it causes, what changes it brings, all these things we will be studying. So, today we will be briefing about thermometry. So, the first part of this segment, that is heat, is thermometry. What is meant by thermometry? If you see, what do we mean by thermometry? Thermometry simply refers to measurement of temperature. And what is the device that is used to measure the temperature? So, temperature is measured by a thermometer, which is well known to all of you. So, we can see here is a diagram, an elementary diagram of a thermometer. Yes. So, thermometer, when we construct a thermometer, we actually look for certain properties of substances which can vary with temperature. Whenever we construct a thermometer, we look for certain properties of any substance which can vary with temperature. And what is the best property that we can select? Any such property which varies directly with temperature. So, what will be the effect when something varies directly with temperature? We can apply unitary method. Like 10 rupees, if I say there is something, suppose you go to buy say sweets, just random example, if you go to buy sweets and you have a rate, okay, like say 1 kg sweet is 500 rupees, just example, 1 kg sweet is 500 rupees. So, if I ask you what is the price of 200 gram sweets, so you can easily find that 1 kg 500, so 200 grams means 1/5, 1/5 means 100 rupees. So, here we are applying unitary method. So, when something varies directly with another thing, so we can use unitary method. So, same applies for measuring temperature. Whenever we measure temperature by a thermometer, we select such a property which can vary directly with temperature. So, what we use over here is, as you can see, an elementary thermometer where we are using mercury as the liquid inside a glass bulb. So, in the thermometer outside you can see a glass tube, and inside also there is a thin capillary tube which is made of glass, this one, and in this capillary tube here you can see is a glass bulb which is a reservoir of mercury. So, here mercury is there, and what happens that when we bring this thermometer in contact with any object, so the thermometer comes in thermal equilibrium with the object. That means its final temperature will become same as that of the object. Understood? Listen carefully. Its temperature will become same as that of the object. Now, what will happen to this mercury? This mercury will expand due to heat, and gradually you will see that from the glass bulb the mercury will rise slowly in the capillary tube, and it will rise to a certain level at equilibrium. So, you can see that at a particular temperature, this mercury inside the capillary tube has rise to a particular height. Now, you can see that on this scale I have marked different points. This scale is there. So, this one, if the lowest point is considered, this part, so we will give it a name for this thermometer. This I am writing as LFP, which is lower fixed point. Now usually what we do, we take LFP, this you can see, this LFP, this we take as the ice point. This we call as the ice point. Now what is ice point? Ice point is that temperature where ice melts. So this is considered as the lower fixed point or reference point. So when you dip it in a bowl containing ice, then you will see that the mercury will rise up to this level. So if the ice is melting, so at melting, you know what is the temperature, melting temperature, 0 degrees Celsius. So when you will dip it in a bowl or bucket of melting ice, then you will see that the glass bulb will rise up to this division. Similarly, if you dip it in boiling water, then we get a particular level. So we are taking as the upper reference or upper fixed point. So upper fixed point, which we will denote as UFP. Now this UFP we generally take as steam point. Steam point, that is when water boils. So when you dip it in a bucket of boiling water, then you will see that mercury will rise up to this level, which is the upper fixed point. So we fix two points, LFP and UFP. Now you can see what is the concept here. The temperature change with respect to the lower fixed point, it is found to be directly proportional to the length of mercury column. So what we say from here is, in a thermometer, we select the property, like here we are selecting the height of the mercury column. So height of mercury column in the capillary tube, the thin tube you can see, this is directly proportional to the temperature change with respect to lower fixed point. It is directly proportional to temperature change with respect to lower fixed point. Now here you can see that this temperature LFP, suppose I am taking, and you can see here that the mercury has rise to a or gone to a particular height. So let's take this temperature as theta. I am not giving it any units, I am just saying that this temperature is theta. So you can see that when we compare it height wise, so you can see a particular height, let's take this height as L. So L height denotes a temperature change of theta from the lower fixed point. So what is the temperature change? Theta minus LFP. Theta minus LFP temperature change corresponds to a height of how much? L. Now if you see the height corresponding to upper fixed point, if you check this one, let's take this length as capital L. So when will the height of the mercury column reach capital L? When the temperature will become UFP. And when will the height of mercury column become small l? When the temperature will become theta. So these all divisions you can see, they are equal divisions. So all the divisions on this scale are equally spaced. So we have all equally spaced divisions. All equally spaced divisions. How many divisions are there in total? You can see the total number of divisions is actually equal to UFP minus LFP. Whatever is the temperature difference between the upper fixed point and lower fixed point, that many equal divisions we take. I will tell you what by example. You will see the next slide, but understand this total length capital L corresponds to a temperature difference of upper fixed point minus lower fixed point, whereas small l corresponds to a temperature difference of theta minus lower fixed point. So for any thermometer we have this property that upper fixed point temperature, height of the mercury column is directly proportional to temperature change. So we can say if I take small l by capital L, so for small l length, what is the temperature change? Theta minus LFP. And when you take capital L, what is the temperature change? UFP minus LFP. Can you see? So this value remains same for all thermometer scales. Listen, this is very important. Listen very carefully. Any temperature scale you take or any thermometer scale you select, for all of them this value small l by capital L will remain fixed. Why I am saying so? Because this thermometer is given. Now it can be a Celsius thermometer, it can be a Fahrenheit thermometer, it can be an absolute thermometer measuring in Kelvin, it can be a temperature measuring thermometer when the unit or scale is Rankine. There is a thermometer which has a scale called Reumer. Different I can give units or thermometer scales, Celsius, Kelvin, Fahrenheit and so on. Now this is fixed, mercury has rise up to this, so small l by capital L, this value will remain same for all thermometer scales. Okay, so this is the basis of any thermometer. What we have to remember, small l by capital L, that is theta minus LFP by UFP minus LFP, this remains same for all thermometer scales. So basically I am just converting the units. So if I go through different thermometers, I will see that UFP and LFP will be different for different thermometer scales. Generally for Celsius, LFP is taken as 0 degree Celsius. Let me tell you, for Celsius scale, LFP is taken as 0 degree Celsius and UFP is taken as 100 degree Celsius. I hope all of you know this thing. Clear? LFP, again repeating, is 0 degree Celsius and UFP is 100 degree Celsius when we take a Celsius scale. But if we change it to other scales like Fahrenheit and Kelvin and all, so these values will change. Okay, let's come to that. So I hope this is clear to all of you. This point again, theta minus LFP by UFP minus LFP remains same for all. Okay, let's see. Now, as I was talking of, in the next slide you can see we have different thermometer scales over here. Now what I have done is, if you see this line, this lower line, this I am calling as ice point, which was the lower fixed point. This dotted line you can see the lower one. Now you can see this line, upper one, this is steam point or the upper fixed point. For different thermometers we have different values. Now what happens here, if you see the first one, this one is Celsius scale thermometer. Second one, if you see, this is Fahrenheit scale. The third one you can see, which is called as absolute scale. When the temperature is measured in Kelvin, we call this scale as absolute scale. Next, you can see this one is Reaumur scale, and the last one over here you can see this is Rankine scale. So we have different scales over here, and you can see for Celsius LFP 0 degree 100 degree UFP, 32 degree Fahrenheit LFP, 212 degree Fahrenheit UFP. Similarly, Kelvin 273 to 373, Reaumur 0 degree R to 80 degree R, Rankine 492 degree R to 672 degree R. This is actually not R, this is Rn. Make this as Rn. Now what happens here? As I said, that the entire length is divided into equal number of divisions, and I told you how many equal number of divisions? As much the difference between UFP minus LFP, that is the number of divisions. Now see, UFP minus LFP is how much? 100 minus 0, so 100 equal divisions. UFP minus LFP in Fahrenheit, 212 minus 32, 180 equal divisions. Here 373 minus 273, 100 equal divisions in absolute scale. In Reaumur scale, 80 degree R and 0 degree R, 80 equal divisions. In Rankine, you have again 180 equal divisions between 672 and 492. So the same length, you are seeing the same length, it has been divided into different number of divisions for different thermometer scales. Clear? This thing I was talking of. So this length, as I said, we take this length only as capital L, which corresponds to divisions here. Now the second thing, as I said, if suppose I select any particular temperature, and I select this length as small l. Now in Celsius, let's call this temperature as theta C. This particular temperature in Fahrenheit will be theta F. In Kelvin, this particular temperature will be theta K. In Reaumur scale, let's take this temperature as theta R. And in Rankine scale, this particular temperature we are taking as theta Rn. So you can see a particular small length L corresponds to these temperatures in different scales. Now going by what I said, again writing what I said was small l by capital L is equals to theta minus LFP by UFP minus LFP. This is what we did. So is same for all. So as I said, same for all scales. So just equate it. So what I can write, first if I start with theta C minus lower fixed point is 0, UFP minus LFP is how much for Celsius? It is 100. If I go for Fahrenheit, theta F but lower is 32 divided by how much? 180. If I go for Kelvin, theta K minus 273 by 100. If I write for Reaumur, theta R minus 0 by how many divisions? 80. If I write for Rankine, theta Rn minus what is the lower value? 492 divided by 180. So this is what we get for different thermometers. Understood? No need of memorizing. Just remember that theta minus LFP by UFP minus LFP remains same for all thermometer scales. Is it clear? So whenever we are asked to relate any two different temperature scales, we can always do by this method. Is this clear to all of you? Please let me know first. Okay, now this was to relate temperatures. This expression relates temperature in different scales. But sometimes what happens that instead of temperature, they will ask you of change in temperature. They will ask you about change in temperature. They are asking here for temperature relation, but what if they ask you what is the relation between temperature change in different scales? We will see example of that also. So if temperature change in different scales are to be related. Now if they ask for temperature change, so what you will use here, see, when we want change, so theta c, instead of theta c you will write delta theta c. So what is delta theta c? It is the change in Celsius temperature or change in temperature in Celsius scale. We will say delta theta c is change in temperature in Celsius scale. So we will just take the change here. So theta c becomes delta theta c. Now 0 is a constant, no change, leave it like that. Divided by 100 will be 100 only. Now come here, theta f will become delta theta f. This will denote temperature change in Fahrenheit scale. 32 is a constant. Any constant, what is the change in a constant? It is 0. Listen carefully again. Theta f, the change is delta theta f. 32 is a fixed temperature, constant value. So constant value's change is 0. Divided by 180. Now when we see the next one, if you see the change here, 273 is a constant, so only this will change. So delta theta k divided by 100. So if you write in Reaumur delta theta r by 80, and if you write in Rankine delta theta rn divided by 180. So from here we get a very important point. What is that important point? If you see, when we relate temperature changes in different scales, so we can see from here that the temperature change in Celsius by 100 and Kelvin also by 100, 100 will cancel, means Celsius and Kelvin temperature changes are equal always. For example, we can say 20 degree Celsius change or 20 Kelvin temperature change are equal. Temperatures are not equal, the changes are equal. So in Celsius and Kelvin, the change in temperature is same. Similarly, you can see Fahrenheit and Rankine 180. So we will say change in temperature in Fahrenheit scale is same as the change in temperature in Rankine scale. These are two very important results, remember. So change in temperature in Celsius and absolute scale are same, change in temperature in Fahrenheit and Rankine scale are same. So when they ask you to relate temperature, use this relation. When they ask you for change, just this replace by delta theta, that's it. Is it clear to all of you? Please let me know first. So let us go through examples so that this thing can be, the use of this thing can be understood. Now we have few questions over here. Let's see the first question. Very basic question. The temperature of a body is 95 degree Fahrenheit. What will be its reading at Celsius scale? Now it is simply reading based. So as I said, so theta c minus LFP by 100 is equals to theta f minus LFP divided by 180. This is what we use. This is Celsius and Fahrenheit. Now they have given the body temperature in Fahrenheit is 95 and they are asking what is the reading in Celsius scale. So we can very easily find this. So what is theta c from here? 100 by 180. So this, whenever you solve, 25s are 100 and 29. So this will become 5 by 9 times 95 minus 32. That's it. This is 5 by 9 and this is 63. 35. So 35 degree Celsius, that is the fourth option. Yes, correct. Vaishnavi, Koteshwar, ASR, okay, correct. So 35 degree Celsius. Understood this? Clear to all of you? Whenever we have to compare temperature scales, what we do? Give a fast reply so that we can move to the next question. Okay. Now next question we have, there are two different temperature scales A and B which are related as A minus 42 by 110 is equals to B minus 72 by 220. So they are saying at which temperature two scales have the same reading. Both the scales are having same reading, means suppose that A and B, both the temperatures are equal. Let's take it as theta. So same reading, so A and B can be taken as theta. Now we have to find the value of theta where they give same. So just put theta minus LFP for A is 42 and UFP minus LFP is given as 110. Similarly here we have B also is theta minus 72 divided by 220. Simple question again, just cross multiply. 2 theta minus theta is theta. This will become 42 2s are 84, minus 84 goes that side, becomes plus 84 minus 72. So this will become 12 degree. So the correct option over here is which one? The option C is correct. Clear to everyone? Yes. So C option will be correct. Fine. So same temperature, how to solve it, you got it? Okay. Let's move to the next question. The absolute zero temperature in Fahrenheit scale is, when they say absolute zero, what do you mean by this term absolute zero? This absolute zero temperature, this is nothing but 0 Kelvin. 0 Kelvin is called as absolute zero. So they are asking what will be the absolute zero temperature in Fahrenheit scale. So again now you can use Kelvin and Fahrenheit. So we can use theta K minus lower is 273 divided by UFP minus LFP is 100. When they are asking in Fahrenheit, theta F minus 32 and we saw 180. Now in Kelvin, since it is absolute zero means 0 Kelvin. So just put here 0. So they are asking this value. So again here we have 0 remains 0 only, 9 gets multiplied. So here we have minus 9 3s are 27, 7 9s are 63 to 65, 9 2s are 18, 6, 2 4 5 7. And here we are having 5 theta F minus 32 into 5, 160. So from here theta F will be minus 2457 plus 160 divided by 5. This will be in Fahrenheit. So you can calculate that. Please solve and check. This now you can do. That was not Celsius, it is given Fahrenheit. Okay. If it was Celsius, then it would be minus 273 degrees Celsius. But when you solve by this, you will get the correct answer. Clear? Option A is not correct. Option A would be correct if it was Celsius. Minus 273 degrees Celsius, it is given Fahrenheit. Understood? Is it clear to all of you? Okay, so shall we proceed to the next question? Now, as I said that this temperature rule applies to any scale, so we have a thermometer reading freezing point of water as 20 degrees Celsius and boiling point as 150 degrees Celsius. How much thermometer reads when the actual temperature is 60 degrees Celsius? So now they are saying when actual temperature is 60, so what we know for any scale, we can use theta c minus 0 by 100. We know this is for actual Celsius scale. When we have actual Celsius scale, then we take temperature theta c lower as 0 and UFP minus LFP is 100. But now we have a faulty scale. This is a faulty Celsius scale because they have given other UFP and LFP for that, but you can still use this. Now in that we are taking as theta c dash minus LFP. In that case, freezing point of water is taken as 20 and boiling point is taken as 150. So UFP minus LFP. So this you can use everywhere. You can use this everywhere. So they are asking what is the actual temperature. They are giving the actual temperature, I think, how much the thermometer will read when the actual temperature is 60. So actual temperature is given as 60 degrees Celsius. So they are asking that this thermometer, the faulty one, will read how much. So we can solve from here now. What we can say, 60 by 100 is equals to theta c dash minus 20 by 150 minus 20 is 130. So from here theta c dash, if you see, will be equal to 13 into 6, 78 plus 20, which is 98 degrees Celsius. So that is option A. So this applies not only for actual scales, even for faulty scales. Means you can say faulty scale is also another thermometer scale whose lower and upper fixed points are different. So this type of questions can also be asked. We can very easily solve them. Is it clear to all of you? Okay. One more type of questions come in thermometer, where what they do, as I told, that thermometers are so made that you always select such property of any substance which can vary directly with temperature. Okay. So when we use that property, we call it as a thermometric property. I hope all of you have taken screenshots of this one. Okay. Let's quickly go back and discuss something which is called as a thermometric property of a substance. So when we say that temperature is changing linearly, the property of a substance is changing linearly with change in temperature, that property is called thermometric property. We denote it as X. So what is it? Any property that varies continuously with temperature. Let's take temperature as theta. So any property that varies continuously with temperature, that is known as thermometric property. Generally, we select X, which varies directly word over here means linearly with temperature. Like you saw, just to go back, we saw that this all the temperature change and the length. So we see that the length of the mercury column was directly changing or directly varying with temperature change. That's why we use this unitary method. So whenever we have any property that varies directly, we can apply unitary method over here, right? So example, there are several examples. One is length of mercury column. There are other also. Resistance of a platinum wire. You will later on understand there is a type of thermometer which uses the concept of electrical resistance. Then we have pressure of an ideal gas at constant volume. We have volume of an ideal gas at constant pressure. You will study all this in the upcoming portions where we will be discussing about the gas laws and all. So you will see that all these are thermometric properties because they vary linearly with temperature. Okay, volume of an ideal gas at constant pressure, pressure of an ideal gas at constant volume. There are laws also for this, Charles law, Gay-Lussac's law, all of them you will be studying. So here basically whichever is the thermometric property, it has to vary linearly. So if something varies linearly, so we can always write x as a theta plus b. Linear equation is always of the form a theta plus b, where a and b are constants, thermometric constants. Okay. So when these are constants, now what we do, suppose at ice point, if you are taking 0 degree Celsius, steam point 100 degree Celsius, and at a temperature theta degree Celsius, suppose the value of x we are giving names as x naught, x 100 and x theta. So suppose at different temperatures the values of x are calculated like this. Then what we can say from here is, if you substitute over here, then what you can say, we can write x 100 is equals to a theta we are taking as 100 plus b, first equation. When you are putting x as x naught, temperature here is 0, so it will just become b. And when we are putting theta degree Celsius, we will get a theta plus b. So when we solve these three equations, from here we get the value of b. When you put it in first equation, you will get a, and when you will put the value of a and b in third equation, we get a very, very important result. From equation 1, 2 and 3, we get a very important result. Theta by 100, theta by 100 is equals to x theta minus x naught by x 100 minus x naught. Similar relation which we got, LFP UFP relation, same like that. So theta by 100 is also equals to x theta minus x naught by x 100 minus x naught. So any thermometric property x, it can be length of mercury column, it can be resistance, it can be pressure, it can be volume, whatever it is, it obeys this relation. If you are using a Celsius scale, then theta by 100 is equals to x theta minus x naught by x 100 minus x naught. So whenever we are asked any question on this, we can easily solve this. Is it clear to all of you? So I will just take 1 minute, and so that this thing theta by 100 is x theta minus x naught by x 100 minus x naught. So just 1 minute of time I will be taking so that you understand this thing. A mercury thermometer dipped in melting ice has length of 2 centimeter of mercury column. Here they are talking of length. When you dip it in melting ice, length is given 2 centimeter. So here x is given as length of mercury column. Now they are saying when you dip in boiling water, its length become 10 centimeter, and in ice it is 2 centimeter. So if the length of mercury column is 7 centimeter on dipping in a liquid, what is the temperature of liquid? So what we can say, if the liquid temperature is theta, so theta by 100 I just told is x theta. X theta here will become L theta, x naught will become L naught, x 100 will become L 100, x naught will become L naught. That's it. Now here at 0 degree Celsius the length is given as 2 centimeter. 2 centimeter. At 100 degree Celsius at in boiling water its length is 7 centimeter. I'm sorry, it is 10 centimeter, not 7, 10 centimeter. And in a liquid whose temperature is to be found, it is given as 7 centimeter. So they are asking temperature of the liquid. So we can very easily find from here. So what is the temperature of the liquid? So theta is 7 minus 2, 5, 10 minus 2, 8 into 100. So 500 by 8, that is 250 by 4, 62.5 degrees Celsius. That's it. Clear to all of you? So this is how we use thermometry concepts in questions. Yes, correct. 62.5. So I hope I was able to make you understand the basics of thermometry. That will be all for this lecture. Thanks to all of you.
Hello, good morning students. So today we are here to discuss next topic. In last lectures we have studied about organic chemistry, that is completed structural isomerism. Now we'll start from physical chemistry, that is oxidation, reduction, redox reaction. You have heard about redox reaction in class 10th also. Simultaneous oxidation and reduction where takes place, that is called as redox reaction. So now new topic of physical chemistry is redox reactions. Now in these 10 or 11 lectures we'll cover this complete redox reaction, and we will discuss about basics of oxidation reduction, electronic concept, how to find oxidation number, oxidation state, and then balancing of all the redox reaction. So these all topics will cover in this 10 or 11 lectures for complete redox reaction, and this is very important topic of physical chemistry. Every time in NEET you will find 1 or 2 questions directly based from this chapter. Stoichiometry is also based on redox, that is gram equivalent concept. So this is a very important topic. So if we break this redox into two parts, this RED represents reduction and this OX will represent oxidation. So can we say that in redox both terms are coming, oxidation and reduction? So a chemical reaction in which simultaneous oxidation and reduction takes place, that reaction will be considered as redox reaction. So what we write? A reaction in which simultaneous oxidation and reduction takes place is called as redox reaction. Clear? So this is simple definition of redox, but here two new terms we have written. One is reduction and one is oxidation. So if we can identify what is oxidation, what is reduction, then only we can tell about that which reaction are redox, which reactions are non-redox. So the classical old concept of oxidation and reduction are these addition and removal of elements like hydrogen, oxygen, electropositive element, electronegative element. Now hydrogen, oxygen, simple. Now what is meaning of electropositive or electronegative element? The elements which have tendency to lose electron, They will form cation means positive charge. So they are called as electropositive element. And elements which have tendency to gain electron. So after gain of electron, they will form anion, that is negative charge. So they are called as electronegative elements. So metals like sodium, magnesium, calcium, mercury, all these are electropositive elements. And if we write about non-metals like halogens, fluorine, chlorine, bromine, iodine, so they are considered as electronegative element. So first we write complete detail for oxidation process. So if we take heading as oxidation, so which process is termed as oxidation? Now students, you have to tell me how many things you know about oxidation, that which process is oxidation. You have to tell about what you have studied in class 10th about oxidation process, that which process is called as oxidation. Removal of oxygen, reduction of hydrogen, removal of hydrogen, oxygen both, no. So either one thing will take place, either addition of oxygen or either removal of hydrogen. And in terms of electropositive and electronegative element, we have also write. So there are four processes which can be termed as oxidation. So let us start from first point. So first point is addition of oxygen to any element or compound is called as oxidation. So if oxygen is added to any element or if it is added to any compound, then that process will be called as which process? Oxidation process. So we'll write these four types. So if we take example, let us take magnesium. Magnesium is element. If we add oxygen to it, what is formed? MgO. I am not writing balanced equation, just reactant and products I am writing. So Mg plus O2 gives MgO. Now magnesium is element. If you check what is present here, magnesium is a element. Now this element is converted to MgO. It means what is added from Mg to MgO? Oxygen is added. So this process will be termed as which process? Oxidation. So what we say here, magnesium is getting oxidized and gets converted to MgO. No need to write for O2. What we are written here, that magnesium is oxidized and gets converted to MgO. Now this is for element, but we can add oxygen in compound also. If we take carbon monoxide, now carbon monoxide is a compound. Now if we add oxygen to it, what is formed? Carbon dioxide. Now if we see from here, CO2, CO2, what is added from CO to CO2? One oxygen atom is added. So this process is called as which process? Oxidation process. So first point of oxidation is very important point, that addition of oxygen to any element or any compound is called as which process? Oxidation process. So this is first point about oxygen. Now we can write for addition of electronegative element also. Let us write second point. Now second point about oxidation is addition of electronegative element. Is called as oxidation. It is not necessary that if only oxygen is added, then that process will be oxidation. If any electronegative element other than oxygen, oxygen is also electronegative, other than oxygen any electronegative element is added, that process is also called as which process? Oxidation process. So if we take example, FeCl2, it is ferrous chloride. Now Cl2 chlorine is added and it is converted to ferric chloride, FeCl3. Now if we check this process, FeCl2 is converted to FeCl3. Now which element is added here? Chlorine is added. Now you have to tell chlorine is electropositive or electronegative. You tell me chlorine is electropositive element or electronegative element. Fluorine is electronegative element. So what we are adding here? Electronegative element to FeCl2. So we can say oxidation of FeCl2 takes place. So this FeCl2 to FeCl3 is which process here? Oxidation process. So do not say that complete it is only oxidation, it is a complete redox. But which species is oxidized? FeCl2 is oxidized to FeCl3. So these are 2 points for addition. First we have written addition of oxygen. Second is addition of electronegative element. Now next will be removal. Now next is if we remove hydrogen from any compound. Removal of hydrogen from any compound is also called as oxidation. Now hydrogen cannot be removed from element because it is H2. We have to remove hydrogen from any compound. That process will be called as which process? Oxidation process. So if I write one example, H2S plus Cl2, what is formed? Sulfur plus HCl. Now if you check only this process, H2S2 sulfur. Now H2S is a compound. From this 2 hydrogen are removed and it is converted to sulfur. So this is removal of hydrogen from any compound. So this process is also termed as oxidation. Is it clear? Whenever hydrogen is removed from any compound, that process is also called as which process? Oxidation process. Any doubt in this? Removal of hydrogen. Remember, removal of hydrogen will be from any compound, not from any element. Now next 4th point is removal of electropositive element from any compound is called as oxidation. Okay. So if I write one example, let us take KMNO4. K2MNO4. Oxidation we have to write removal of electropositive. So we'll take K2MNO4 and oxidation. What is formed? Let us say KMNO4 plus KOH. So this is reaction given that KMNO4, K2MNO4 plus O2 gives KMNO4 plus KOH. Now if you see this K2MNO4, what is present here? How many potassium are present? 2. And potassium is which type of element? Electropositive element. And in KMNO4, how many potassium are present? 1. So what is present here? Removal of, what is removed from here? Potassium, that is K positive, electropositive element. And removal of electropositive element is called as which process? Oxidation process. So K2MNO4 is oxidized to KMNO4. Now very good question here. What is name of this K2MNO4 and name of KMNO4? You tell, what is name of this K2MNO4 compound? Now name of this K2MNO4 is potassium manganate. And KMNO4 is potassium permanganate. Just remember these names also. K2MNO4 is called as potassium magnate and KMNO4 is called as potassium permanganate. Reason is because this MnO4 2 negative ion, this is called as which ion? Magnet ion. And this MnO4 negative is called as which ion? Permanganate ion. Now, if you check, we have written 4 cases for oxidation. In class 10th, we have studied only about, so how did this hydrogen came? In every redox reaction, we will find H2O also. I am saying I am not writing complete reaction. In redox reaction, what is present? H2O. We are not writing complete reactions. I am only just taking case of oxidation. So listen now here. So total there are 4 process for oxidation. First is if we add oxygen to any element or compound, that is also called as which process? Oxidation process. If you check, addition of oxygen to any element or compound is called as oxidation. Second one is addition of electronegative element is also considered as which? Oxidation. Next is removal of hydrogen from any compound is called as which process? Oxidation. And last is removal of electropositive element from any compound is also called as oxidation. So 2 addition and 2 removal. Addition is for oxygen and electronegative element, and removal is for hydrogen and electropositive element. So if any of this case arises, these all are termed as oxidation. And what will be reduction? Reverse of this will be considered as reduction. So in oxidation, what we have added? Oxygen or electronegative element. So in reduction, these will be removed. Removal of oxygen and removal of electronegative element. And in oxidation, what we have removed? We have removal of hydrogen, and one is removal of which element? Electropositive. And in reduction, what we have to do? Addition. Addition of hydrogen and addition of electropositive element. So let us take next case for reduction. Same 4 cases we'll write, first for addition, then for removal. So in case of reduction, let us write first addition of hydrogen, because in oxidation we are removing hydrogen. Now we have to add hydrogen to any element is called as reduction. We can add hydrogen in any compound also, to any element, or it can be any compound. So if we take example, let us take Cl2, and what we are adding here? Hydrogen. It is getting converted to HCl. Now if you see here, Cl2 to HCl, what is added here? Hydrogen is added into chlorine. So what we can say here, reduction of chlorine takes place. So what we write here, reduction of Cl2 takes place. Because here in Cl2 what we are adding? Hydrogen, and it is converted to HCl. So addition of hydrogen to any element is considered as which process? Reduction process. Any doubt in this? This is reverse of oxidation. In oxidation there is removal of hydrogen, and here it is addition of hydrogen. Is it clear? Now next, if we take second is addition of which element we have to add now? Electropositive element. Electropositive element is also called as which process? Reduction process. Now if I write example here, let us take HgCl2 plus SnCl2. What is formed? Hg2Cl2 plus SnCl4. Now this is a complete redox reaction. We are not writing complete redox, only we have to check about which process is oxidation, which process is reduction. Now if we take HgCl2 converted to Hg2Cl2, so what is added from this reactant to product? 1 mercury, and mercury is which element? Electropositive. So addition of electropositive element will be considered as which process? Reduction process. So what we write here, that reduction of HgCl2 takes place. HgCl2 is called as mercuric chloride. So here reduction of mercuric chloride takes place because in HgCl2 is converted to Hg2Cl2. So what we are adding here, one mercury is added, that is electropositive element, and addition of electropositive element is considered as which process? Reduction process. Okay. Now after this, what we have to write about removal. So now in case of oxidation, oxygen is added. So in case of reduction, oxygen will be removed. So what we write here? Removal of oxygen from any compound is called as which process? Reduction process. Okay. So if I take one example, zinc oxide ZnO plus carbon, what is formed? Zn plus carbon monoxide. Now we have to only consider this ZnO2 Zn. Now from ZnO2 Zn, what is removed from here? Oxygen is removed, and removal of oxygen from any compound is called as which process? Reduction process. So what we can say here, reduction of which compounds will be there? Which compound takes place? Zinc oxide is reduced to zinc, that is Zn. And last point about removal is removal of electronegative element. From any compound is called as which process? Reduction process. Now what are electronegative element? Electronegative elements are those elements which have tendency to gain electron, like fluorine, chlorine, bromine, iodine, oxygen, nitrogen. So if I write example for this, FeCl3 plus H2S, it is converted to FeCl2, HCl plus sulfur. Now we have to only consider this part. FeCl3 is converted to FeCl2. So in FeCl3, how many electronegative element chlorine are present? 3. In FeCl2, how many electronegative chlorine atom are present? Only 2. So 3 to 2 means 1 chlorine is removed, and removal of electronegative element is called as which process? Reduction process. So all these are cases for reduction. So 4 cases for oxidation and 4 cases for reduction. And if I write conclusion for these all, for oxidation and reduction, so it is very easy to write conclusion. So we'll classify this into 2 parts. One we write for oxidation and one we write for reduction. Okay. So in oxidation, addition you have to remember. Addition of which element? Oxygen or electronegative. That is called as which process? Oxidation process. And for removal, what we have to remember? Removal of hydrogen or electropositive element. This is also called as oxidation. So in addition, 2 cases, oxygen electronegative element is added, then it is which process? Oxidation. Hydrogen or electropositive element is removed, then also which process? Oxidation. Now for reduction, it will be reverse. For reduction, if we write first case for addition, which elements are added during reduction process? So which are removed in oxidation, that will be added in reduction process. So what we do write? Hydrogen. Addition of hydrogen or addition of electropositive element is called as which process? Reduction process. And if we have to write for removal, removal of oxygen or electronegative element, that is also called as which process? Reduction process. So if you remember only this conclusion for oxidation and reduction, we can easily find out which species is getting oxidized and which species is getting reduced. And in same reaction, if oxidation and reduction takes place, that will be called as redox reaction. Now first check about this oxidation and reduction, 4 points. Any doubt in this? Check these all 4 cases. First, old classical concept, then we move from oxidation, reduction, how electronic concept, gain of electron, loss of electron. But first we have to only focus on this. Now next is, if I take one example, you have to tell me this reaction is redox reaction or not. And if it is redox, which species is getting oxidized and which species is getting reduced? Very simple example from class 10th NCERT. Can aluminum powder is used as oxidation agent? Wait for thermite process. We are moving so fast. We are studying basic points. You will learn all these things. But first tell me, this is redox reaction or it is non-redox reaction? If it is a redox reaction, which species is getting oxidized, which species is getting reduced? Carbon is oxidized, Zn is reduced. Sir, once again, can you say electronegative and positive? Simple. Compounds elements which have tendency to lose electron, which have tendency to lose electron are considered as electropositive, like metals, and which have tendency to gain electron, that is non-metals, are considered as electronegative. Oxygen is also electronegative element, but is other than oxygen there can be any other electronegative element which can be added or removed. Now let us check this point, ZnO2Zn. Now this is which process? It is removal of oxygen, and removal of oxygen is considered as which process? Reduction. So we can say here ZnO is getting reduced, and here carbon is converted to carbon monoxide, and addition of oxygen is called as which process? Oxidation. So in this what we have written, it is addition of oxygen, that's why it is termed as oxidation, and here it is removal of oxygen. So this is termed as which process? Reduction process. Clear? So it is a simple example of redox reaction. Now when we discuss oxidation numbers, then we leave these all topics, addition or removal of any element, then we directly move from oxidation number. So if you find this year also in NEET there is a question, which of the following is a redox reaction or which of the following is not a redox reaction. These type of question every time they will ask. Very simple question. If you do not remember that oxidation number concept, from these also you can identify that which reaction is redox reaction, which reaction is non-redox reaction. Now let us move to next 2 simple points. One is oxidizing agent and one is reducing agent. So what is meaning of oxidizing agent? Now the substance which oxidizes other and itself gets reduced, that is called as which type of agent? Oxidizing agent. So remember this, it is oxidizing other compounds and itself it will get reduced. So it is called as oxidizing agent. So what we write here, it's substance which oxidizes other and itself gets reduced is called as oxidizing agent. Which oxidizes other and itself gets reduced is called as which type of agent? Oxidizing agent. And if we write reducing agent, Now reducing agent is which reduces other and itself gets oxidized. So if I write, so what is definition here? Substance which reduces others and itself gets oxidized is called as reducing agent. Clear? So if I give one example, same we take that example, ZnO plus carbon, Zn plus Cu. Now we consider what is nature of carbon. It is oxidizing agent or it is reducing agent. Now if you check here, carbon is converted to carbon monoxide. So itself it is getting oxidized and it reduces which compound? ZnO. So we can say here carbon is acting as which agent? It is acting as reducing agent. So it reduces ZnO to Zn and itself getting oxidized from carbon to Cu. And this is definition of reducing agent, which reduces other and itself gets oxidized is called as which agent? Reducing agent. Now check, any doubt in this oxidizing agent, reducing agent? Then I will give you one question where you have to tell which is oxidizing agent and which is reducing agent in that redox reaction. So this is simple, easily we can identify which is oxidizing, which is reducing. So let us write one question. Find oxidizing agent and reducing agent in following reactions. First is MnO2 plus HCl, it gets converted to MnCl2 plus Cl2 plus H2. And second reaction is Fe2O3 plus CO, Fe plus CO2. Now whenever there is a redox reaction, if one is oxidizing agent, another will be reducing agent. So in these two reactions you have to tell which is oxidizing and reducing agent. First solve for first part. MnO2 is oxidizing agent and HCl, some students are saying reducing agent. Okay. Now move to second part, Fe2O3 plus CO. MnO2 oxidizing agent. It is correct. MnO2 is oxidizing agent and HCl is reducing agent. Now second part you have to solve. Fe, there is no Fe, complete compound, Fe2O3CO. In complete compound you have to tell, not any element. Fe2O3 is which agent? Oxidizing agent. And CO is which agent? Reducing agent. Now let us write solution for this. Now how we'll find this? MnO2 plus HCl, MnCl2 plus Cl2 plus H2. So let us consider this first part, MnO2 to MnCl2. Now removal of oxygen. Removal of oxygen is called as which process? Reduction. So we can say MnO2 is undergoing which process? Reduction process. Let us write from HCl to Cl2. Removal of hydrogen is called as which process? Oxidation. Now it is very easy to write which is oxidizing agent, which is reducing agent. Now species which itself gets reduced, it will oxidize other. So it will act as which agent? Oxidizing agent. It will oxidize other and itself it is getting reduced. And if we write for HCl, itself it is getting oxidized. So it will reduce other species. So it is acting as which agent here? Reducing agent. So how to easily identify species which is undergoing reduction itself? They are which agent? Oxidizing agent. And compounds which are undergoing oxidation itself, they are acting as which agent? Reducing agent. So this is also in class 10, same two reactions I have taken from there. And these type of questions are directly coming in NEET also. They can ask which of the following is oxidizing agent, which of the following is acting as reducing agent. Now if I take second example is Fe2O3 plus CO. Fe plus CO2. So let us take Fe2O3 is converted to Fe. Removal of oxygen is called as which process? Reduction process. And CO is converted to CO2. Addition of oxygen is called as which process? Oxidation. Now easily we can identify species which itself getting reduced, they will oxidize other. So they will act as which agent? Oxidizing agent. And for CO if we write, species itself getting oxidized will reduce other. So it will act as which agent? Reducing agent. Now check, any doubt in these two questions? That which of the following is oxidizing agent, which of the following is reducing agent? Okay. So this is simple, easily we can find. So whenever you have to find oxidizing agent or reducing agent, just check that which of the following will get oxidized, which of the following will get reduced. Okay. Now one important point, listen this. In chemistry part, in these online classes, what we have covered? Mole concept, stoichiometry. Next, what we have covered? Nomenclature and basics of organic chemistry, representation, primary, secondary, tertiary, carbon, hydrogen. And third, what we have discussed structural isomerism. Now, meanwhile, when up to first time physical classes will not start, join Telegram channel. So I will share test for all these. So in today or tomorrow I will give test for mole concept. There will be 20 or 25 questions from mole concept. You have to attempt those questions for practice. Next test will be from nomenclature and basics of organic chemistry. That mole includes stoichiometry. And after that, one test for structural isomerism. So that you will not feel that you are not getting anything. Join Telegram channel. I will share 3 tests for these. And this is for your practice. So that you should revise all these topics also meanwhile. So basic question, what we have studied in online classes, from that only basics of these all. 3 tests I will share. So students who have not joined Telegram channel, join that channel. In that channel, we will share these 3 tests. Okay. Today or tomorrow, mole concept. Today by evening or in tomorrow morning, I will send for mole concept. Then I will send for nomenclature next day for structural isomerism. And in start of the class, I will give you answer key for that. Okay. So in next class, but we start electronic concept of oxidation and reduction. So students, thank you for today.
Good. Which chapter we had done previously? Did you read that? Let us go with the last class topic, that is cytokinesis. Okay, last class topic is cytokinesis. No, it was meiosis, I guess. Meiosis, Harshit. Yeah, not cytokinesis, it was about meiosis. We are done with the cell cycle. Yes, Deeptika, very good, cell cycle. See, when humans started observing the nearby surroundings, they started thinking that, okay, which things we can make use from the environment, like for example plants, animals, taming of animals. Okay, from the plants we are getting the food items. So like that they started thinking. So earlier all the organisms were considered by humans only for three things: food, shelter and house. They were thinking about the food, clothing, shelter, the basic needs of humans. Food we need, shelter we need, and even clothes also we need. So all these organisms were giving us these three things. We used to think like whether this organism can give me food or not, whether it can give me clothes or not, whether it can give me shelter or not. So all the basic needs were considered in classifying the organisms around us. We will see so many organisms around us, like plants, animals. In animals also different categories. In plants also different categories. But all these organisms are considered by humans whether they are useful for or not, for us or not. So earliest classifications were based on the need or use of the organisms. Okay, based on the 3 points basically, that is food, shelter and clothing. Okay. So earlier the scientists were there, like so many scientists were there, so they used to think like that. But the first scientist who attempted scientifically to classify these organisms was Aristotle. Aristotle. He was the first scientist to give the scientific attempt to give the classification. Okay, he made the classification scientifically. He made the first attempt to give the scientific classification for the first time. You know who is he? Aristotle. He is father of biology and father of zoology. He is father of biology as well as zoology. So Aristotle was the first scientist to attempt the scientific classification for the first time, and he is considered as father of biology and father of zoology because he classified the animals into two groups: animals with red blood, animals without red blood. So he has done the animal classification first, so he is considered as study of animals is called as zoology. So he is considered as father of zoology. But why we are calling him as father of biology means he also classified the plants based on the morphological characters. He took one morphology like height of the plant roughly, okay, and he classified the plants into trees, shrubs and herbs. Trees the largest one, shrubs and the small ones are herbs. So that is why he is considered as father of biology and then father of zoology. He not only classified animals, he also gave little bit classification of plants also. But for that he considered morphology. The basic structures, the height of the plant was considered by him. Later, first he was the person to attempt the classification, scientific base of classification. Later, so many other scientists came into the picture and they started giving, like Linnaeus. He gave the two kingdom classification. For that two kingdom classification, all organisms were kept under two kingdoms. One is plants and another one animals. Okay. So several scientists, they grouped all these organisms on the earth into two groups, plants and animals. It is very easy to understand also. But they have considered only one point for doing this classification. The point which they considered was cell wall, whether it is present or absent. Okay, you know that plant cells, they will be having the cell wall. Animal cells, they don't have the cell wall. Okay, but here this classification was very easy and everybody should understand easily, very easily. But the problem comes here, whether the cell wall material, is it same in all if it is present or different. Okay, whether that organism is unicellular or multicellular. Unicellular means which is made up of only one cell. Multicellular, it is made up of different cells, many cells will be there in that. Or whether that organism is a prokaryote with a primitive nucleus, or that organism is an eukaryote with a true defined nucleus. Then there are the problems with autotrophism, heterotrophism. All these points were not clarified by this two kingdom system of classification. Though it is very easy to understand, it gave so many challenges to the scientists to understand, okay, whether these are autotrophic, heterotrophic, multicellular, unicellular, mode of nutrition, what is it? Okay, then mode of reproduction, what is it? Okay, then cell wall, if not cell wall, what is that? The extra thing that is present. If cell wall is there, what are the cell wall materials? Is it cellulose? Is it pectin? Is it something else, calcium carbonate? Like that, all these problems came for the two kingdom classification. But this is most of the time, okay, in the initial days, this classification was accepted by so many people because it is very easy to understand, because only one point is considered, whether cell wall is present or cell wall is absent. So in the plants, all the bacteria, cyanobacteria, algae, fungi, plants, these are all kept under this. The animals, only animals were kept under that with the protozoans like amoeba, paramecium, like that, they were under this. It started with that Linnaeus two kingdom system. Later some other scientist came and he gave the problem, he solved the problem, saying that Ernest Haeckel, he gave the three kingdom system of classification. He classified them separately. He gave the third kingdom, that he separated the unicellular eukaryotes. Protistans were separated from this. Okay. So Ernest Haeckel, he gave the three kingdom system of classification by adding the third kingdom, that is Protista. So he separated from the plants all the unicellular eukaryotes. He separated all unicellular eukaryotes from this. And he created a separate kingdom that is called as Protista. So like that, plants, animals were there already. The third kingdom added by Ernest Haeckel was Protista, which includes all the unicellular eukaryotes which are separated from the plants. Okay, he created that. Then after him, again the problem of autotrophism, heterotrophism, prokaryotes, eukaryotes, that problem did not solve. So it went for the four kingdom classification, which was given by Copeland. This was given by Copeland. He added the fourth kingdom, that is Monera. He actually separated all prokaryotes like bacteria, blue-green algae, like bacteria and all blue-green algae, BGA, nothing but blue-green algae, which are also called cyanobacteria, were separated. All prokaryotes he separated, Copeland, from that plants kingdom. Okay, and he made the next kingdom called as Monera. Monera include all prokaryotes. For example of the prokaryotes are bacteria and blue-green algae. Blue-green algae are also called as cyanobacteria. Okay, like that the four kingdom classification was made. Even after this, okay, the problem of little bit like heterotrophism, then absorptive mode of nutrition, that problems were not solved. Absorptive mode of nutrition. So because of that, the five kingdom system of classification was given. Five kingdom system of classification was given by You know who gave this system? R.H. Whittaker. R.H. Whittaker. He added the fifth kingdom, that is fungi or mycota. It is also called mycota. He separated the fungi from plants and he created the fifth kingdom, that is fungi or mycota, which had shown the absorptive mode of nutrition. Absorptive type of nutrition was shown by this. So in that way, first two kingdom classification was there, which many of the people for many years they followed. But later they came to know so many problems are there in considering two kingdom system of classification, because so many organisms did not find place in the two kingdoms. Then third kingdom came by the addition of Protista, where all unicellular eukaryotes were separated. Then fourth kingdom came by separating all the prokaryotes into Monera. Then finally R.H. Whittaker in 1969, he gave the five kingdom system of classification, by which he added the fifth kingdom, that is fungi was added. Okay, I hope all of you understood. See, now you know that this is the R.H. Whittaker's 1969 five kingdom system of classification. In this, organisms are classified into prokaryotes. Prokaryotes belongs to Monera. All prokaryotes belongs to Monera. Then in eukaryotes, all eukaryotic organisms are divided into unicellular eukaryotes were placed under Protista, whereas multicellular ones are placed with cell wall under phototropic organisms Plantae. Multicellular, cell wall containing phototrophs. Multicellular, many cells are there and they contain the cell wall and they are phototrophs. They can perform photosynthesis. That were placed under Plantae. Multicellular with cell wall is present but they show heterotrophic mode of nutrition, were placed under fungi. Multicellular eukaryotes, heterotrophic, were placed under fungi. They have the cell wall which is made up of chitin or chitin. Then multicellular eukaryotes without cell wall, they don't have the cell wall is absent. That created the kingdom Animalia. They were kept under Animalia. This is the five kingdom system of classification. This is R.H. Whittaker gave the five kingdom system of classification. When he gave this, he brought together different groups of organisms together, because criteria of classification keep on changing. So Chlamydomonas was actually unicellular. Okay, Spirogyra, it is a multicellular organism, okay, but it belongs to the algae. That all of them will be clubbed together and they got separated, like Chlamydomonas, Chlorella, Paramecium, Amoeba. Paramecium, Amoeba were taken from animals. Chlamydomonas and Chlorella were taken from plants, and these four were kept under Protista. So like that, all these scientists, they have taken from that kingdoms and they mixed everything to create that five kingdom system of classification. So after this also, okay, six kingdom system of classification and domains of classification was given by Carl Woese. One scientist is there called Carl Woese. He gave six kingdom classification. Like he separated Monera into eubacteria or simply bacteria, and next group archaebacteria. In simple terms, these are called as archaea. So Carl Woese, what he had done was he divided Monera kingdom into two kingdoms, eubacteria and archaebacteria. So first one, second one, okay, then third, fourth, fifth, sixth. Sixth kingdom classification was given like that. The same person, he gave three domain classification, three domain system of classification or three domain classification, where he considered Monera this as prokaryote. This is the first domain. Monera was placed under first domain, that is prokaryote. Okay, and in that he separated these two, no, in the Monera. So he created the first one as eubacteria, second one as archaebacteria. So two domains are there. Monera got separated, no, which include all prokaryotes. So he separated that as eubacteria and archaebacteria. So two domains are there. First domain is eubacteria, second domain is archaebacteria. Remaining all were kept under these all Protista, Plantae, Fungi, Animalia. They were all coming under eukaryote. So it is called as eukaryote. Just the prokaryotes got separated as two domains and two classifications, eubacteria and archaebacteria. Afterwards, the third domain is eukaryote, that was given by the Carl Woese. Okay. Why this keeps on changing with different systems of classification, different domains means because the point what the scientists are considering for classification keeps on changing. Some people will consider only morphology, some people considered the cell type, some people considered cell wall, some people considered body organization, some people considered mode of nutrition, like that. Different points are considered by each of the scientists and they gave their own systems of classification. Even today the system goes on, the classification system goes on, and it has so many classifications. So many kingdoms are also there, but you don't have that in your syllabus. I hope all of you understood this. Who gave that 6 kingdom classification? Which are the 3 domains? First one, which is the first one? Carl Woese, yes, correct. Carl Woese, okay. 3 domains are there. What are those 3 domains? Eubacteria, archaebacteria, third one eukaryote. Okay. Yeah, archaea, bacteria and eukarya. Eubacteria, eukarya. Yes. Now let us consider which points were considered by R.H. Whittaker for doing that 5 kingdom system of classification. Okay. These are the 3 domains. Now let us see which points are considered by R.H. Whittaker. Criteria for his classification. First, he considered cell type. Okay. Then he considered body organization. Then he considered mode of nutrition. Then he considered mode of reproduction. Then finally he considered phylogenetic relationships. Phylogenetic relationships. So here you got a new term, phylogenetic means evolution. Based on evolution he arranged. That means which are the first ones, which are the second ones, third ones, like that. So first he considered cell type, whether it is prokaryotic cell or eukaryotic cell. Then the body organization, whether it is unicellular, multicellular. Okay. Mode of nutrition, whether it is autotrophic or heterotrophic. Okay. Mode of reproduction, whether it shows only asexual reproduction or sexual reproduction. If it is that, what is that kind of reproduction named as? Phylogenetic relationship, which are the first ones, which are the last ones. In between, what are the kingdoms that are present? These are the points considered by R.H. Whittaker for giving that 5 kingdom system of classification. Okay. All of you can see here the 6 kingdom classification where you have the first ones eubacteria, unicellular prokaryote, archaebacteria, unicellular eukaryotes. Okay, first ones eubacteria, second ones archaebacteria. Unicellular prokaryotes, unicellular eukaryotic is given, but it is not eukaryotic, it is prokaryotic only. They got some of the features of eukaryotes. Then protista, unicellular eukaryotes are there. They can be multicellular, okay, but mainly it is eukaryotic unicellular. Later, from Monera, these two will come under Monera. So, Monera are the first oldest group. Monera had given rise to Protista, second group, evolved from the Monera. From Monera on different lines, this is the second one, third, fourth and fifth, all the three, plants, animals and fungi, they evolved from Protista. So, the ancestors of plants, animals and fungi are the Protistans, ancestors of Protista are Monerans. This is how they evolved. This is the evolution phylogenetic relationship. Next, all of you, you can see in the NCERT book, it is given, a table is given, which explains the R.H. Whittaker 5 kingdom classification, which points are considered by him. You can see cell type is given. In Monera, cell type is prokaryotes. Only one kingdom with all the prokaryotes is Monera. Then remaining all the four, Protista, fungi, plantae, animalia, these are all eukaryotes. Cell organization or body organization, it is also called body organization, whether it is unicellular or multicellular. Monerans and Protistans are unicellular, fungi multicellular, and only one organism is a unicellular, mostly multicellular. Mostly multicellular, one or two will be there unicellular. Plants multicellular, animals multicellular. Cell wall, because the first two kingdom classification was based on the cell wall, whether it is present or absent. So, he included that point also. Cell wall is present in most of these Monerans. In Protistans, some will have the cell wall. In fungi, cell wall is present. In plantae, cell wall is present. But in animals, cell wall is absent. Next point is nutrition, mode of nutrition, whether it is autotrophism, phototrophism, chemotrophism, heterotrophism, like that. In the Monera, phototrophs and heterotrophs are there. In autotrophs, chemoautotrophs are there. This mode of nutrition will be learning further when you come here. Protista, their heterotrophism and phototrophism is also there, autotrophic as well as phototrophic. Fungi all are heterotrophs, plants all are autotrophs, and animals all are heterotrophs, heterotrophic mode of nutrition. Then mode of nutrition, in the nutritional class only, what kind of mode of nutrition they show. Absorptive mode of nutrition by the Monerans, then by the Protistans absorptive or ingestive. Absorption of food materials or ingestion, eating that, consuming that. Fungi absorptive mode and plants say mostly absorptive mode, but it is actually phototropism, synthesizing. Animals mostly ingestive. Okay, these kingdoms are placed according to the evolution point only, that is called phylogenetic relationships. They are placed like that. Yeah, I hope all of you understood. All of you read up to this much, and tomorrow we'll continue with the kingdoms.
Hello everyone. So I'm back here with all of you. So let us start today's session, and in today's session I will be talking about animal tissues again. Okay, so when we discussed all the 4 types of tissues, at that time we have not discussed them in detail, and obviously in today's class also I am not going to discuss every tissue in detail, okay, but we'll just see the overview of the animal tissues, and then I can tell you the epithelial tissue locations today. Okay, so when we have studied epithelial tissue, at that time we have mainly focused on the classification of the epithelial tissue. So I have told you types of tissue, on what basis they have been classified. Today I will tell you the location of different types of epithelial tissue, everyone. Yes, everyone. So are you ready? Are you excited? Everyone tell me in the chat section. Are you ready? Yes, everyone. Are you ready? Shall we start today's session? Yes. Everyone is saying yes. All are excited. So yes, listen to me carefully and let us start the tissues, discussing tissues. So, all right. Now, let me give you an overview. Let me give you a brief overview. We have started talking about animal tissues. Animal tissues. Animal tissues, beta. So, animal tissues are present in the multicellular animals. All the animals of the animal kingdom are multicellular, beta. But in all the animals, there will not be the tissues. The very first phylum in which animal tissues came is the second phylum, Coelenterata. Yes or no, everyone? Porifera is also animal, but it does not have tissues. It has cellular level of organization. So, tissues came for the first time in which animal phylum? Yes, everyone? Yes, obviously, Mantri Pragada. I am going to teach you again when once you will join, each and everything will be taught to you in detail. Now what we are studying, yes, Shravani, I remember your name. So, whatever we are going to study here now in the online classes, just we are making you comfortable with the topics, beta. We are making you comfortable with the topics, with the chapters, okay, with the subject, with us, okay. That is why we have chosen this platform, so that we'll keep on interacting with you and you will be tuned with us. Okay, so now let us start the class. So I have taught you animal tissues. They are, what is the definition of tissue? Yes, everyone. What is the definition of tissue? It is a group of cells. I have told you it is a group of cells. These group of cells are similar in origin, in structure, in function. Okay, so group of cells similar in origin, structure and function. Obviously, that group of cells will play the same function. It is meant for a particular function. Yes, animal tissues. Now, in the animal tissues, I have told you 4 types. Yes, tell me quickly in the chat section what are the 4 types of animal tissues. Yes, everyone, tell me the 4 types of epithelial of animal tissues. Everyone, tell me in the chat section. So everyone is asking when will the college starts. Beta, you will come to know soon when will the college will start. But for now, I think till 25 we are going to have of online classes only, and after 25 very soon you will be coming here, okay, and we will start the offline classes. Yes, everyone, epithelial tissue, connective tissue, muscular tissue, nervous tissue. Yes, Harshit. Yes, yes. So everyone is telling me the correct answer. Epithelial tissue, epithelial tissue, connective tissue, connective tissue, muscular tissue, muscular tissue, and beta nervous tissue, and nervous tissue. Yes, these are the 4 types of tissues: epithelial tissue, connective tissue, muscular tissue, and nervous tissue, beta. Can you quickly tell me the origin of all these tissues? Yes, everyone. Yes, everyone. Can you quickly tell me the origin of all these tissues? Yes, tell me quickly in the chat section. What is the origin of epithelial tissue? What is the origin of connective tissue? What is the origin of muscular tissue? What is the origin of nervous tissue? Yes, yes. Which germ layer? Jaya, Charan. Which germ layers? So, epithelial tissue, it is all the germ layers can give rise to epithelial tissue. Ectoderm, mesoderm, as well as endoderm. If we talk about connective tissue, it is mesodermal in origin. If we talk about muscular tissue, it is also mesodermal in origin. But if we talk about nervous tissue, it is ectodermal in origin. Very, very important point. Now, let me discuss with you the epithelial tissue once again. Okay. Let me discuss with you the epithelial tissue, everyone. Epithelial tissue. So, in the epithelial tissue, can you tell me the types of epithelial tissue, everyone? Can you tell me the types of epithelial tissue? Epithelial tissue. Epithelial tissue is meant for which function? Sankar Manna. Ma'am, in NCERT book, which chapter is this, ma'am? Beta, you will not find this chapter in the new NCERT. You will find this chapter in the old NCERT in the unit structural organization in animals. Okay. So, you will find this in the old NCERT chapter. The unit name is structural organization in animals. Yes, Vaishnavi. Yes. It is simple and complex. Yes. You can tell it is simple and compound, not complex. Complex or compound is same thing. Okay. But so epithelial tissue, mainly two types are there. First is simple. One is simple and another is compound. Simple and compound. Simple is meant for covering and compound is meant for protection. Simple is having one layer of cells, single layer of cells, single layer of cells, single layer of cells. Compound is having many layers of cells, more than one layers of cells. Okay, compound is having more than one layers of cells. Okay, so that is why their function is different, beta. Simple is having single layer of cells, single layer of cells, and compound is having more than one layer of cells, So the function of simple is covering. The function is covering or lining, whereas the function of compound is protection, beta. Yes, do you remember all these things? Protection. So in epithelial tissue, you will see in between the cells, there is very less intercellular space and very less intercellular substance. And these cells are compactly packed, very compactly packed. Okay. So this is epithelial tissue. You can see the cells are compactly packed. Now the shape of cells can be different. On the basis of the shape, we have different types of simple epithelium. Yes, so can anybody tell the three basic shapes now? Simple epithelium, types of simple epithelium, everyone. Tell me quickly in the chat section. Types of simple epithelium. Three basic shapes are there. So now let me move on to the next page and now let me talk about the simple epithelium, beta. Okay. So I am going to talk about the simple epithelium, and in today's class I will be talking about the location of different types of simple epithelium. Okay. So simple epithelium. Okay. I am going to talk about the types of simple epithelium, beta. Types of simple epithelium. So the very first type is simple squamous epithelium. Simple squamous epithelium, beta. Okay. Next type is going to be simple cuboidal epithelium. Simple cuboidal epithelium. Then there will be simple columnar epithelium. So first of all, I will talk about these three and the locations of these three. Alright everyone? Alright. Now, simple squamous. Beta, in the squamous, the cells are very, the cells are very thin and flat. Whereas in cuboidal, they are cube-like. Okay. Whereas in columnar, they are cylinder-like. So if you see, squamous cells are like this. Squamous cells are like this with a flat nucleus. They are like this, beta. So they can be present where it is just the requirement of the covering or lining, but it will not help in the production of or secretion of something, or it will not help in the absorption. Okay, because cell the surface area is not that much. Okay, so cell is very, very thin. The squamous cells are very thin flat cells, and they have a flat nucleus in the center. So their main function is to cover. Okay, so you will find what is the location. Today I am basically talking about the location beta. Location. So if you see the location of squamous epithelium, you will find it in the lining of blood vessels. Lining of blood vessels. You will find in the lining of lymph vessels beta. Lymph vessels. Okay. You will find it in the lining of lumen of heart. Lumen of heart, where you will tell it endothelium. You will find it in the cavity, coelomic cavities, lining of coelom, coelomic cavity, coelomic cavity, okay, lumen of heart, lining of blood vessel, lining of lymph vessel. Then you will also find it in the lining of Bowman's capsule beta. Do you know Bowman's capsule? Bowman's capsule, do you know? You will find it in the Bowman's capsule. You will find it in the loop of Henle. Loop of Henle. You will also find it in the alveoli of lungs. Alveoli of lungs beta. Alveoli of lungs. So everywhere, at all these places you will find the simple squamous epithelium. Yes, nephron. So many people are giving the correct answer. Loop of Henle, Bowman's capsule are the part of nephron. Okay, alveoli is present in your lungs. Inside your lungs, alveoli is present. Alveoli. Okay, so you can remember it like this. See here. I'll be telling you little bit of the Bowman's capsule. This is Bowman's capsule beta. Then this is proximal convoluted tubule. Then this is loop of Henle. This is loop of Henle. Okay, this is loop of Henle. Then this is distal convoluted tubule and it is opening into the collecting duct. This is collecting duct beta. This is collecting duct. Okay, this is collecting duct. So you can see the parts of nephron here. You can see this is Bowman's capsule. It is Bowman's capsule. Okay, this is PCT, proximal convoluted tubule. Beta, this is loop of Henle. This is DCT, distal convoluted tubule. This is collecting duct. So if here somebody will ask you, where is squamous epithelium present? Simple squamous epithelium. So you can tell simple squamous epithelium is present in the Bowman's capsule like this. It is present in the Bowman's capsule like this. It is lining the Bowman's capsule here like this. So you know that filtration of blood occurs here. So filtration is the function of simple squamous epithelium. We can tell that filtration is, it is forming the filtration membrane. What can be the function? Bowman's capsule is not the part of glomerulus beta. Glomerulus is different. Bowman's capsule is different. Bowman's capsule is this. It is part of renal tubule. One more part is glomerulus, which is coming here. Glomerulus is like this. See everyone. This is blood capillary. Okay, this is network of blood capillaries. So this is afferent arteriole. This is afferent arteriole. This afferent arteriole is coming into the nephron to provide the blood. Blood is there, and then this afferent arteriole will divide and form a capillary network here. Okay, this is known as glomerulus beta. This is glomerulus. This is glomerulus. When these capillaries will join and come out, it will make efferent arteriole. All this you will study when we will talk about nephron in detail. Okay, so we are not going into the details of nephron today. Just I have drawn this nephron to tell you the location of the different types of epithelium. Simple epithelium. If we will say simple squamous epithelium is forming a filtration membrane, you should know where it is forming the filtration membrane. Where it is forming the filtration membrane? In the nephron. Because here blood capillaries will be there, na? Blood vessels will be there. Blood vessels are also lined by simple squamous epithelium. Bowman's capsule is also lined by simple squamous epithelium, and that is making the filtration membrane here. Okay, that is making the filtration membrane here. Are you understanding why we can say simple squamous epithelium forms the filtration membrane? Because filtration will take place. Yes, Ratna, yes, you are correct. So filtration will take place here. Filtration of blood will take place here. Okay. So here it is forming the filtration membrane. Then I have told you in loop of Henle also, beta. Loop of Henle also you will find, in loop of Henle also you will find simple squamous epithelium like this. You will find simple squamous epithelium like this. You will find simple squamous epithelium is lining the loop of Henle. Okay, so when I will show you with the help of the diagram, it will imprint here in your mind and you will never forget. Similarly, if you see the alveoli, beta, this is the alveoli of the lungs, and this alveoli is also lined by simple squamous epithelium like this. You can see simple squamous epithelium. Then around the alveoli, you know, so many blood vessels are present. So many blood vessels are present around the alveoli. So this is a blood vessel I am showing you. And in this blood vessel also, you can see simple squamous epithelium. Okay, this is simple squamous epithelium. So this is a blood vessel. This is a alveoli and this is a blood vessel. Here you know diffusion will occur. Diffusion. Oxygen will go from here to here. Oxygen will go from alveoli to blood, and carbon dioxide will go from blood to alveoli. So exchange of gases, diffusion takes place. Okay, this diffusion membrane. So can we say that diffusion membrane is also formed by simple squamous epithelium? Yes, everyone, tell me in the chat section. So are you understanding the function of simple squamous epithelium? It forms the diffusion membrane. It forms the filtration membrane. It forms the lining or covering. Yes or no, everyone? Yes or no, everyone? Yes. So here it is forming the diffusion membrane. It is forming the diffusion membrane. Okay. And here we are talking about the filtration membrane. Here in the glomerulus and Bowman's capsule, it is forming the filtration membrane. Filtration membrane. So these are the functions of simple squamous epithelium, beta. Simple squamous epithelium. So are you understanding the location and functions of simple squamous epithelium? Yes, everyone tell me. Yes, everyone tell me. Are you understanding this? Yes, yes. All right. Now I will tell you the next epithelium, and that is the cuboidal. Simple cuboidal epithelium, beta. This is simple cuboidal epithelium. If you see simple cuboidal epithelium, you are going to see smooth. Smooth means without any modification. It is smooth. The cuboidal cells, these are the cuboidal cells. Let me show you the cuboidal cells. Cube-like cells. Cube-like cells. Okay. Cube-like cells. Cube-like cells like this. So if these cube-like cells does not have any modification, it will be smooth cuboidal. It can be called as smooth cuboidal, but it can also have some modification. Do you remember the modifications? Yes, everyone, tell me in the chat section quickly if you remember the modifications. What can be present over the cube-like cells and the columnar cells? Which type of modifications can be present? Yes, all subject corner, villi. Yes, villi can be present. That is not villi, beta, that is microvilli. Okay, villi is different, microvilli is different. Yes, is there any lagging? It is showing like that. Okay, yes, Satyam, no, Madhuri, ciliated, yes everyone, cilia. So cilia is present, okay, villi is present, cilia is present, microvilli, yes everyone. So everyone is giving me the correct answer. Yes, so can we tell where microvilli is present? Can we tell brush bordered? It is brush bordered cuboidal. Brush bordered cuboidal. In the brush bordered cuboidal, microvilli will be present. And then another is ciliated beta. Ciliated epithelium. Ciliated cuboidal epithelium. So if you want to know the location of smooth cuboidal, brush bordered cuboidal and ciliated cuboidal, let me tell you the location of these. Okay, the location of smooth cuboidal. Beta, in the ducts of glands. Do you know so many glands are there in our body? Glands are there. And the glands which have ducts, they are not endocrine glands. Endocrine glands does not have ducts. Okay, exocrine glands have ducts. So some of the glands have ducts, some of the glands do not have ducts. Those glands who have ducts, in most of the glands which have ducts, you will find cuboidal epithelium. Okay, you will find which epithelium everyone? Cuboidal epithelium. Now, if you know about thyroid gland, there are thyroid follicles. In the thyroid gland, there will be thyroid follicles. These thyroid gland is here beta. Thyroid gland is present here on either side of trachea. Okay, you will study about the thyroid gland in the chapter endocrine system, or you can say chemical coordination and integration, which is the last chapter of human physiology. So thyroid gland has thyroid follicles, and these follicles have the cells. These cells are cuboidal in shape. Okay, then gonads, very, very important, example, gonads. What are gonads? Yes everyone, what are gonads? Yes, Maleshwar Rao, what is your doubt beta? So gonads are beta those organs which produces the germ cells, which produces the ovum and the sperm. So in case of males there will be testis, in case of females there will be ovaries, and they produce these cells which are known as gametes. Okay, gametes. Male gamete is sperm, female gamete is ovum. In spite of these, along with these gametes, these gonads also produces hormones. They also produces male sex hormones and female sex hormones. Alright. So gonads are endocrine gland as well as exocrine gland. Okay, it acts as both exo and endocrine gland. These gonads also have cuboidal epithelium beta. This cuboidal epithelium here in the gonads can be named as germinal epithelium. So if somebody will ask you germinal epithelium, you should able to tell germinal epithelium is cuboidal epithelium or columnar epithelium or squamous epithelium. Germinal epithelium is present where? In the gonads, and germinal epithelium is an example of cuboidal epithelium. Which cuboidal epithelium? Smooth cuboidal, simple smooth cuboidal epithelium. Alright everyone. Now one more location which is very, very important. I will show you in the nephron. DCT. In the DCT, you remember DCT? Here I have shown you DCT. So in the DCT also cuboidal epithelium is present. Which cuboidal beta? It is smooth cuboidal. Like this. These are the cuboidal cells. These are not squamous. These are the cuboidal cells. Cuboidal epithelium. Simple cuboidal epithelium. Here in the loop of Henle, Bowman's capsule, squamous epithelium, but here cuboidal epithelium, cube-like cells you will see. You will see here cube-like cells. Okay, cube-like cells, cuboidal epithelium. Are you understanding this? DCT, cuboidal epithelium. Now, if we come to the PCT beta, PCT, there are cuboidal cells but with the modification, and this modification is beta microvilli. So, very important location. Brush bordered cuboidal epithelium is present in PCT. PCT, proximal convoluted tubule, PCT, beta PCT, you know, here in the PCT, maximum reabsorption will occur. Why maximum reabsorption? Because of the presence of more surface area, and more surface area is due to the brush bordered epithelium, or you can say microvilli. So, brush bordered means what? Brush bordered means presence of microvilli, and you know presence of microvilli increases the surface area. Microvilli increases surface area for absorption. When it increases surface area for absorption, that is why in PCT maximum reabsorption takes place. PCT shows maximum reabsorption. Very important question. They will ask you maximum reabsorption occurs in which part of nephron? So, maximum reabsorption occurs in which part of nephron, everyone? PCT. Always the answer will be PCT. Okay, Ratna beta, we will come to the small intestine. Wait. Okay, we will come to the small intestine. Now, coming to the ciliated cuboidal. Cuboidal ciliated. In your respiratory tract, there are bronchioles. So, if you say bronchioles, there is, you will find ciliated epithelium beta. In the small bronchioles, you will find ciliated epithelium in the small bronchioles. Now, I am going to come to the simple columnar beta. Simple columnar. In the simple columnar, there can be smooth, okay, smooth means without any modification. You will find in your gastrointestinal tract. In your gastrointestinal tract, okay, you will find columnar epithelium, whereas in the intestine you will find brush bordered columnar, but in the stomach you will find normal. Okay, in the small intestine you will find brush bordered, but in the rest of the gastrointestinal tract you will find smooth columnar. So you can remember, see, your gastrointestinal tract is just like a tube. You can say digestive tube. Tube is cylindrical. So like this you can remember that columnar epithelium is present in the gastrointestinal tract. Okay, in your gastrointestinal tract, in your stomach and intestine, smooth columnar. When somebody will ask you the location of smooth columnar, you can tell in stomach and intestine. In stomach and intestine. But if somebody will ask you the location of beta brush bordered columnar. Brush bordered columnar. If somebody will ask you the location of brush bordered columnar, you can tell brush bordered columnar is present in intestinal mucosa. Intestinal mucosa. Mucosa is the innermost layer of the intestine. Innermost layer is known as mucosa. So that innermost layer has the columnar cells with the microvilli. So that is why maximum absorption of your food, digested food, occurs in the intestine beta. Absorption is completed in the intestine. Do you know why? Because of the presence of brush bordered columnar epithelium. So in small intestine, this is intestinal mucosa of small intestine. Intestinal mucosa of small intestine. Are you understanding brush bordered columnar where it is present? Brush bordered columnar where it is present? Intestinal mucosa of small intestine. Now coming to the ciliated. Ciliated beta. Ciliated. Let me tell you, ciliated columnar. Ciliated columnar. Ciliated columnar means presence of cilia, where the movement of some substances are required. Okay, so remember, ciliated columnar is present in most of the respiratory tract. In your respiratory tract, ciliated cuboidal is also present, ciliated columnar is also present. But if somebody will ask you mostly which is present, then you will tell ciliated columnar. So can we write, yes, Tejasvi beta, mucosa means the innermost layer. Innermost layer. See, let us suppose this is a tube, digestive tube. So in this digestive tube, this is the wall, and this wall is made up of 4 layers. I am not going to discuss that in detail, but the innermost which is in contact with the lumen space, that innermost is known as mucosa. After mucosa there is submucosa, after submucosa there is muscularis, and after that outermost is serosa. 4 layers are there. So innermost layer is mucosa. Okay, innermost layer, Tejasvi, is mucosa. Now ciliated, I was telling you ciliated epithelium. So beta, ciliated columnar epithelium is present in most of the respiratory tract. Most of the respiratory tract. In most of the respiratory tract, ciliated columnar is present. Then it is present in beta fallopian tube. Fallopian tube. Why? Because you know, in the fallopian tube, ova will be traveling. Yes or no? Ova, ovum, in the female body, ovum is released by ovary, and then this ovary, from the ovary, the ovum will be released. Now this ovum is taken by the fallopian tube, and in the fallopian tube it will travel to the site of fertilization. Now ovum cannot move. Ovum is not a motile structure just like sperm. Sperm can move, but ovum is immotile. It cannot move on itself. So that is why, with the action of the cilia present in the fallopian tube, that cilia will move the ovum towards the site of fertilization. That is why cilia is very important. Okay, so why in the fallopian tube ciliated columnar is present? For the movement of the ovum. Okay, why in the respiratory tract? In the respiratory tract, mucus is there for the movement of the mucus. Now one more thing I will tell you here, that is the space in your brain and spinal cord. It is known as ventricles of brain and spinal cord beta. Ventricles of brain and spinal cord. Ventricles of brain and spinal cord. Ventricles means the space, and do you know this space is also filled with a fluid. What is a special type of fluid present in your brain and spinal cord? Can anybody tell? Yes, everyone, can anybody tell what is the name of the fluid present in your brain and spinal cord? Anybody? Try. CSF, Jayashri, very good. Jayashri, Nageshwar Rao, you all are brilliant students, yeah. Okay, cerebrospinal fluid. Cerebro means brain, spinal means spinal cord. So there are some spaces, and these spaces have cilia beta. Okay, so which ciliated epithelium? Columnar ciliated epithelium will help in the movement of CSF. So ventricles of brain, this space present in the brain and in the spinal cord also. Okay, CSF is present. For the movement of CSF, which epithelium is present? Ciliated columnar. So I hope today I was able to tell you the locations of these 3 main types of simple epithelium. I have tried to make you understand the locations where in the body you will find these three main types of simple epithelium: simple squamous, simple cuboidal and simple columnar. You will see that in squamous no modification will be present because cell is very thin and flat. But in case of cuboidal and columnar cells, modifications like cilia and like microvilli can be present. So I have told you where you will find the cuboidal epithelium with microvilli, where you will find the cuboidal epithelium with cilia, where you will find columnar epithelium with microvilli, where you will find columnar epithelium with cilia, and where you will find cuboidal and columnar without any modification. I hope each and every location is clear to all of you. Yes, everyone. Dullah Hitesh, going too faster. Beta, I was not fast, I know that. If you have not attended the previous lecture, then you must have, you must be finding it difficult to understand. But other people, are you understanding? Yes, everyone. And it's okay if you are not understanding here, you will come to the class. Once you start offline classes, you will understand each and everything. Okay, okay. So this is the end of today's class, everyone. I hope you, enjoyed the class. I hope you enjoyed the class. Madhuri, thank you so much, beta. All right. Cilia is present in the fallopian tube. Yes. Yes, Deeptika, it is present. In trachea also it is present. Okay. So in fact, the types of simple epithelium are not only these three, but these three are the main types, beta. Two more types are also there. Pseudostratified, glandular epithelium. Two more types are also there, but we don't have time to look upon those two today. So today I have tried to discuss only the three main types. Maybe later in your offline classes we will discuss those. Okay. Thank you everyone. See you tomorrow. Okay. Bye bye. Take care. God bless you all. And yes, I forgot to tell you, but you don't forget to hit the like button and subscribe to this channel. Bye bye. Thank you everyone. Bye bye.